This video will give you the answers and show you the workout for the Systems of Equations 9 Word Problems worksheet. Problem number 1. Mike purchased 3 DVDs and 14 video games for $203. Nick went to the same store and he bought 11 DVDs and 11 video games for $220. How much is each video game and each DVD? So when you start your problem, since you have two unknowns here, the video games and the DVDs, you need to label some variables for those unknowns. We're going to use the variables of X and Y. And the X I'm going to use to represent the DVDs. And the Y will be the video games. Your next step is to go ahead and write a system of equations for your statements that you have up there. So Mike purchased 3 DVDs, so that would be 3X, and 14 video games, so plus 14Y equals 203. And then Nick had 11 DVDs, so that's 11X, plus 11 video games, represented by 11Y, equals 220. Now, in order to figure out what one of the variables equals, we have to isolate one of those variables so that we can use the substitution method. So I'm going to focus on the bottom equation since it has the 11, and the 22 in it. I thought it would be the easiest one to identify a variable on or isolate that variable. So we're going to take and isolate the X. So I'm going to subtract 11X on both sides. And so that's going to bring my equation over here as 11y equals negative 11x plus 220. If I divide everything by 11, that is going to end up leaving me with y equals negative x plus 20. So now I'm able to substitute that information in for the y so that I can solve for either the DVDs or the video games. So let's start our problem. We have our 3x plus 14. In place of that y, we're going to substitute the negative x plus 20 equals 203. Remember, you want to do your distributive property when you get ready. So we're keeping our 3x. 14 times the negative x is negative 14x. 14 times 20 would be 280. At this point, you want to combine your like terms. So 3x minus 14x would be a negative 11x, and bring down the terms you did not use. You now have a two-step equation, so we want to do the inverse operation to the 280, so minus 280 on both sides, so that we can work on isolating that variable. It's going to leave us with a negative 11x and an equal sign. And 280, a negative 280 plus 203 here is a negative 77. And then your final step is to divide both sides by negative 11. So x equals 7. So what that means in the context of our problem is that every DVD is going to be $7 for your DVDs. Now I need to figure out my video games. So I'm going to take my x equals 7 and substitute it into one of my problems. So I substituted into the problem that had all the 11s in it. So I did 11 times 7 plus 11y, equals 220. 11 times 7 is 77 plus 11y equals 220. We would need to subtract the 77 on both sides, leaving with 11y equals 143. And then when you divide by 11, y will equal 13. Now, the y represented the video games, so that lets you know that your video games are going to cost $13 a piece. Problem number 2. At a baseball game, Gina purchased 6 hot dogs and 3 nachos for $24. Frank purchased 8 hot dogs and 1 nacho for $23. How much is 1 hot dog and 1 nacho? So we're going to start with labeling our variables. We're going to use the variable X and Y. You can use others. I just choose to stay consistent with the same variables. Those are for your unknowns. So X will represent our hot dogs, and Y is going to be for our nachos. Your next step is to write out your system of equations. So you go back to your statements. Gina purchased 6 hot dogs, so that would be 6X, and 3 nachos, so that would represent 3Y, equals 24. Frank purchased 8 hot dogs, which would be 8X, plus 1 nacho, so we're just going to do Y, equals 23. So there's your system. Now, if I'm going to use substitution, I need to isolate one of the variables. So I'm going to focus on the second equation. It's the easiest to isolate. I can isolate the Y by subtracting 8X on both sides of the equal sign. And so that would leave me with Y equals negative 8X plus 23. So now we're ready to start substituting. We're going to plug that in. So we've got our 6X plus 3. Instead of Y, we're going to substitute the negative 8X plus 23 equals 24. At this point, you want to make sure you do your distributive property before you start combining like terms. So I'm going to leave my 6X. 3 times negative 8 is a negative 24. Keep your X. 3 times 23 is a positive 69. And bring down the rest of your information. At this point, we do want to combine like terms, so 6X minus 24 is a negative 18X. Bring down your other terms. That leaves you with a two-step equation, so we want to subtract 69 on both sides. (24) minus 69 is going to give me a negative 45. And then our final step would be to divide both sides by negative 18. So X would be 2.5. Now you need to realize that that answer of 2.5 is representing a value of money. So when you think about your hot dog cost, that is $2.50 when you're thinking about actual what it represents. Once I figure out what the X equals, I'm ready to substitute in and figure out what Y equals. So I'm going to take that bottom equation again and plug in my 2.5 in for the X. So 8 times 2.5 plus Y equals 23. 8 times 2.5 is 20 plus Y equals 23. Isolate the Y by subtracting 20 on both sides. So Y equals 3. So that means that your nachos are going to cost $3. And when you get your answers, always think about, does that answer make sense? Is that a possible answer? And in this case, that is definitely a possible answer. Problem number 3, a school play sells adult and child tickets. On Friday, they sold 55 child tickets and 20 adult tickets for $200. On Saturday, they sold 72 child tickets and 36 adult tickets for $306. What is the cost of the individual tickets, of each individual ticket? So we want to identify some variables for our unknowns. I'm going to let X represent the child ticket, so I'm just going to put child, and Y is going to represent the adult ticket cost. Once I do that, I do want to write my systems of equations for my problem. And so we have that Friday they sold 55 child tickets, so 55X, and 20 adult tickets, so plus 20Y equals 200. And Saturday they sold 72 child tickets, so 72X, and 36 adult tickets, so plus 36Y, and that was a total of $306. So there's your system. If I'm going to use my substitution method, then I need to isolate a variable. And sometimes you may have to play around with the equations to figure out which one's going to be the easiest to work with. In this case, I'm going to use the second equation. So I'm going to isolate the y by moving the 72x, so minus 72x on both sides. That's going to leave me with 36y equals negative 72x plus 306. At this point, I do need to divide everything by 36 so I can get my y by itself. And so the y will be negative 2x plus 8.5. So now I'm able to start solving my problem using substitution. I'm going to take my first equation of 55x that starts with 55x. 55x plus 20, and then I'm going to substitute in for my y, negative 2x plus 8.5, and that's going to equal 200. We're going to do our distributive property since I have parentheses involved. So that's going to give me 55x. 20 times negative 2 would be negative 40. Keep your x. 20 times 8.5 is going to be positive 170. And bring down your equal sign in your 200. We want to combine our like terms. So 55 minus 40 on the x's would be 15. Keep the x. Bring down your other terms. You have a two-step equation, so we want to undo the addition by inverse operations. Subtract 170 on both sides. That leaves me with 15x equals, and 200 minus 170 would be 30. And so then my final step is to divide both sides by 15, and x would be 2. Remember, your x represents the child tickets cost, so that would be $2 per ticket for a child. Then we need to figure out our adult cost, and so I'm going to use my 2x. I'm actually going to plug into the exact same equation. You're able to pick whichever equation you want to. So we're going to do 55 times 2 for the x plus 20y equals 200. 55 times 2 is 110. Bring down your other terms. We're trying to isolate that variable, so we're going to subtract 110 on both sides of the equal sign, leaving me with 20y equals 200 minus 110 is 90. And then my final step would be to divide by 20, and y would be 4.5. Remember, the y represents the adult ticket cost, and so that means my adult tickets, if I'm thinking about money, 4.5 is the same as $4.50. Now, if you were asked to write these as ordered pairs, which a lot of times you don't see that in word problems, but if I were to have to write these as ordered pairs, remember the ordered pair would be the x first, which is the 2, and then followed by the y, which is the 4.5, as an ordered pair. So number 4, one gym charges $40 per month and $3 per exercise class. Another gym charges $20 per month and $8 per exercise class. After how many exercise classes will the monthly cost be the same, and how much will that monthly cost be? So this problem is going to set up a little bit different from our other ones. You got to think about earlier on when we first started working with equations and thinking about initial value and rate of change, how those problems looked. So let's just take your first sentence, and we're going to use x and y as our variables. But we're not thinking about the system of equations at this moment. Just think about what it was like if you had initial value and rate of change. So that would start out with one gym charges $40, so that would be y equals $40 would be my initial value, and then $3 per exercise class. So that's my rate of change. That's what changes depending on how many classes you take. So let's think of what our variables could be in this situation. The variable of x is going to represent the number of classes. and my y is representing my total cost. And it's okay to identify your variable titles after you start the problem. It just kind of depends on what's easier for you. So I'm going to draw my line between my equations here. So let's make our second equation of our system. Another gym charges $20 per month and $8 for the exercise class. So that would be y equals $20 per month. It's going to be that initial value each month. And then my rate of change is going to be $8 per class. So since they're both y equals equations, we're just going to set those two equations equal to each other and solve for the variable of x. So that would look like 3x plus 40 equals 8x plus 20. So our goal is to get our x values together. So I'm going to subtract 3x on both sides of the equal sign. That would leave me with my 40, the equal sign. 8 minus 3 would be 5, keep your x, and then the plus 20. Now I'm trying to isolate that variable, so I'm going to subtract 20 on both sides. So that would be 5x equals 20. And then my final step would be to divide both sides by 5. So that leaves x to be 4. Now what I want to take and do with this is I want to take my 4 for my x and substitute it into one of my equations. I'm just going to substitute it into this top one here. So y equals 3, instead of x, I'm going to put the 4 plus 40. 3 times 4 would be 12, so 12 plus 40. So the y is going to equal 52. So the question was, after how many classes will the monthly cost be the same, and what will that cost be? So after 4 classes, the cost is 52 for both programs, or both gyms. If we were giving this as an ordered pair, if that's what you were asked to do, your ordered pair would be 4 and 52. Just depends on what your question is asking. Number 5, we have a 110-point final exam that's made up of 50 questions. Some questions are worth 2 points and some are worth 4 points. How many of each type of question are there? So we're going to start by identifying our unknowns, our x and a y here. X is going to represent the 2-point questions, and that's going to make the y represent the 4-point questions. Now, when we get ready to write our equations here, you've got to think it's talking about number of points, and it's also talking about number of questions. So when you make your equation, you need to be comparing questions added to equal question answers, points added to equal point values. So I have 2 types of questions. I have 2 points and 4 points. So x plus y is going to give me the total number of questions, which is 50 questions. Then I have a point value of 110 points. So my 2-point questions, each x is going to be 2x because it's 2 points. Each y would be 4y, and those points need to add up to be 110 points. Once I've got my equations set up in my system, I need to isolate a variable. You can choose to isolate whichever variable on any equation. We're going to isolate the y on the top one. So I'm going to subtract x on both sides. That's going to leave me with y equals negative x plus 50 so that I can use that to substitute and solve. So our equation, we've got 2x plus 4. Instead of the y, I'm going to substitute in negative x plus 50 equals 110. You need to use your distributive property. So that's going to give me 2x. 4 times negative x is negative 4x. 4 times 50 would be a positive 200. equals the 110. At this point, you do need to combine like terms, so 2x minus 4x would be a negative 2x, and then bring down your other terms that you did not use. We are undoing the addition by using inverse operations, so subtract 200 on both sides. Leaves me with negative 2x, an equal sign, and a negative 90. Now to isolate that variable, I want to divide both sides by negative 2. So that will leave me with x equals 45. So what that means is that there are 45 two-point questions. 45 of those. Now I need to figure out how many 4-point questions. So we're going to take our x value and substitute it into one of the equations. You can pick either one. I'm going to pick the top one because it's the easiest. So we would have 45 plus y equals 50. Subtract 45 on both sides so that I can isolate that y, and y equals 5. So that lets you know that there are 5 4-point questions. Number 6, admission to an amusement park is $10 for children and $15 for adults. On Saturday, there were 1,300 people that entered the park, and $17,250 is collected. How many adults and children, or children and adults, entered the park? So let's set up our variables. We have our x and our y. X is going to represent the number of children. That's one of our unknowns. And y is going to represent the number of adults. Okay. Let's write our equation for our system. So let's think about what made up the number of people getting into the park. That's made up by your children and your adults. So your x plus your y, your two groups of people, is what equals the 1,300 people that entered the park. So then we got to think about the next equation in our system. It deals with the money. So each child's ticket is $10, so that would be 10x. Each adult ticket is 15, so plus 15y equals the amount of money collected, $17,250. Now, in order to use the substitution method to solve this, you're going to have to isolate a variable. So we're going to focus on this bottom equation. We're going to move that x on both sides. So we have x plus y equals 1,300. If I subtract x on both sides, I would have y equals negative x plus 1,300. So that I can do that substitution. All right, 10x plus 15, substitute in the negative x plus 1,300 equals 17,250. Always remember to do your distributive property. So that's going to leave me with my 10x. 15 times negative x is negative 15x. And 15 times 1,300 is going to be 19,500. Bring down your 17,250. You want to combine your like terms. 10x minus 15x would be a negative 5x. Bring down your other terms you did not use. We need to move the 19,500, so we're going to subtract that on both sides, doing that inverse operation. Our goal is to isolate this variable, so that's the reason we're doing this. So when I subtract 17,250 from 19,500, that leaves me a negative 2,250, and I'm going to need to divide that by negative 5. Your negatives are going to cancel out, so that's going to leave us a positive x value of 450. So let's go back to what our x and our y represented. Our x were the number of children, so that lets me know there are 450 children that entered the park. Now, in order to figure out my adults, I'm going to take this value and plug it into that first equation because it's the one that causes me the least amount of work. So my x is 450 plus y. Those totals have to equal 1,300. I will subtract 450 on both sides. And so y is going to give me 850. And in the context of this problem, that y represents the number of adults who entered that park, the theme park. Number 7, a small soda costs 45 cents, a large soda costs 65 cents. 35 sodas were sold with a total of $18.55. How many of each size of soda was sold here? So let's label our variables. Our x is going to be the small soda. Our y will be the large soda. Set up your system of equations. So when you read that first one, you've got small sodas and large sodas should equal up to be a total of 35 sodas. So x plus y equals 35 total sodas. And then you need to use your money to add up and equal your total amount of money. So that would be, small sodas are 45 cents, so 0.45x plus 65 cents on the large one, so 0.65y equals the total amount of money, which is $18.55. In order to use the substitution method, I need to isolate a variable, so I'm going to isolate the y by moving the x to the other side of the equal sign. So minus x to both sides. So y is going to equal negative x plus 35 so that when I can substitute that in and solve for my two unknowns. Okay, so we're going to have our 0.45x plus our 0.65, and then we're going to substitute in our negative x plus 35 equals $18.55, or 18.55. Do your distributive property. So your 0.45x, 0.65 times a negative x is a negative 0.65x. 0.65 times 35 is a positive 22.75 equals 18.55. You do want to combine your like terms, and 0.45 minus 0.65 is going to give me a negative 0.2x. Bring down your other terms that you've not used. We want to subtract 22.75 to both sides. So that I can cancel that out, trying to isolate that variable. And 18.5 minus 22.75 is going to give me a negative 4.2. And then my final step is to divide both sides by negative 0.2. We know a negative divided by a negative is a positive. And then 4.2 divided by 0.2 would give me 21. So 21 represents the x, and that's the number of small sodas. So that's what you would put as your small soda value. To get your large soda value, you would take your 21x and substitute it into one of the equations. I'm going to substitute it into the top equation. So that would be 21 plus y equals 35. I would subtract 21 on both sides of the equation, leaving me with y equals 14. So y being the large soda, that tells me I have 14 large sodas. When you add 21 and 14, if you do not come up with 35, then you would know you have solved your problem incorrectly. So there is a way to check your answers. Number 8, a pet store sells 2 cats and 1 dog for $350. The next day they sell 1 cat and 2 dogs for $475. Find the cost of 1 cat and 1 dog. So let's let our unknowns or our variables be the x and the y. X is going to be cat, and the y is going to be the dog. make your equations for your system of equations. So you've got, reading your statement, 2 cats, so 2x plus a dog, which is y, equals 350. The next day it was 1 cat, which is just x, and 2 dogs, 2y, equals 475. Now on this problem, I do need to isolate a variable so that I can use the substitution method. And so I am going to isolate the y in the top one. So I would do that by subtracting 2x on both sides, and I'm just going to do it from here. So that would give me y equals negative 2x plus 350. That's just a step that we've done in every problem we've worked, so I just kind of took a shortcut instead of rewriting it for you. Now we are ready to substitute. So when we get ready to do this one, we've got our x plus 2, and in place we're going to substitute negative 2x plus 350 equals 475. Do your distributive property. That'd be x. A positive 2 times a negative 2x would be a negative 4x. Positive 2 times 350 is going to be a positive 700. And bring down your total. Combine your like terms. So x minus 4x would be a negative 3x. And then bring down your other terms. You're trying to isolate that variable. So you want to undo the addition of 700. By using that inverse operation, subtract 700 on both sides, leaving me with a negative 3x equals 475 minus 700 would be a negative 225. And then your final step is to divide by negative 3. The negatives do cancel out. And then you end up with your x equaling 75. So in the context of this problem, that lets me know the cost of the cat is $75. So now I have to find the cost of the dog. I'm going to take and substitute that 75 into one of the equations. You can pick whichever one you choose to substitute into. I'm going to the top one, so we have 2 times 75 plus y equals 350. 2 times 75 is 150 plus the y equals 350. To isolate that variable, we subtract 150 on both sides of the equal sign. And y is going to give me 200. So that lets me know that the cost of the dog is going to be $200. If you were asked to write these in an ordered pair, you would do the x first, so that'd be a 75, and the y would be 200. Remember, you can check your answers by substituting both of them into either of the equation and see if they check. Number 9, Martha went to the movies. She purchased some $14 tickets and some $12 tickets. She purchased a total of 9 tickets to buy for $114. How many of each type of ticket did she buy? So let's identify your unknowns. That's going to be your x and your y. We're going to let x be the $14 tickets. And the y is going to be the $12 tickets. Now, this is another problem you got to think about. It talks about money, and it also talks about the number of items purchased. So let's focus on how many total tickets. So what made up our purchase was the $14 and the $12 tickets, represented by the x and y. So this would be x plus y equals 9. The other part of the problem deals with the amount of money. So your next equation needs to deal with the money value of the variables. So my x is $14, so 14x plus 12y. All those tickets together add up to a value of $114. Again, in order to use substitution method, we need to isolate a variable. So I'm going to isolate the y in the top equation. You can choose to do either variable. I'm going to subtract x on both sides, and that would leave me with y equals negative x plus 9 when I get ready to substitute. So in my problem, we have 14x plus 12. In place of the y, we're going to substitute in negative x plus 9 equals 114. Make sure you do your distributive property. 14x stays. X times negative 12 is negative 12x. 12 times 9 is 108. And bring down your equal sign and your 114. You want to combine like terms, so 14x minus 12x would give me 2x. Bring down your other terms you haven't used. We're trying to isolate that variable, so we are going to subtract 108 on both sides. And that's going to leave me with 2x equals 6. And then I'll divide by 2. And so that lets me have the value of x equals 3. So what that means in the context of the problem is that there were 3 $14 tickets sold. So there's 3 of these. In order to figure out how many $12 tickets were sold, we need to substitute that x value back into one of the equations. You can choose to substitute it into either one. I'm going to go into the easy one of the x plus y equals 9. Our x is 3, so that'd be 3 plus y equals 9. Subtract 3 on both sides, and y would be 6. That lets me know that there were a total of 6 $12 tickets sold.